Alright, we're going to continue 17A. So these are the problems that are kind of like 9 through 12, alright, on that worksheet. So let's take a look. Yeah, we'll just do this one. So it's 2, it's a little bit thicker. 2 times the cube root of 3, that's supposed to be a little 3 right there, cube root. And then plus 4 cube root of 24, and then minus the cube root of 81. Thank you. Alright, so what do you see different on this than what we did in those last problems? Yeah, you got addition and subtraction, absolutely. Okay, so remember, with addition and subtraction, with variables, you can only add, what was the expression that you learned probably in pre-algebra, algebra 1? You can only add what kind of things? You can only add blank blank, like terms, very good. Okay, you can only add like terms. So when you think of square roots, for instance, let's keep this here for a second, let's just backtrack a little bit. If I had like the square root of 2, like 3 square root of 2 plus 5 square root of 2. You could look at this as if it was like 3x plus 5x. Right? The square root of 2 are the things that make this a like term. Even though they're not variables, they're constants, it still acts like it's a like term. So I got 3 of these plus 5 of these. So what would my answer to this be? Think of it as 3x plus 5x. It would be what? 8x. But it's not x this time, it's what? It's 8 square root of 2. See what I did? I didn't really take the square root of 2 and add it to the square root of 2 to get something else, but I did take the coefficients, the 3 and the 5, add those together and keep the term the same. Everybody with me on that? Very, very close to adding, like terms with x, y, and z and that kind of stuff. What if you had this? What if you had 3 square root of 2 plus 5 square root of 3? How would you add those together?
You can.
That's right. Not unless you put them as decimals and add the decimals. But as far as these terms right here, you really can't add those together. They're different terms. This is the square root of 2. This is the square root of 3. They're different terms, and you can't get 8 of anything. All right, so it's like adding 3x plus 5y. Would you be able to do anything if it was 3x plus 5y? No, you wouldn't.
Just to leave it like
That's
that.
right. You just leave it like that. There's nothing you can do with that to simplify it. All right? Nope, you can't change it. There's nothing to change it to. Square root of 2 won't simplify. The square root of 3 won't simplify. Now, if you could simplify them into the same terms, yeah, you would go ahead and do that. But in this situation, you can't. All right, so that's a good question you had because that's what we're going to do up here. Let's take a look at this. Can I simplify this first term right here? Is there anything I can do to that to simplify it? No, there's not. Okay, because there's only one 3 in there. It's cube root of 3, so there's nothing I can do with that. So I'm just going to rewrite it 2 times the cube root of 3. But what about this right here?
24 can be broken.
Yeah, let's take 24 and break that down, just like Tiffany said. Okay, so let's put the 4 here, and let's put the cube root here. Now let's think of 24. What can you write for 24? 6 times 4, right? Or let's say 4 times 6. So 4 is that, and 6 is that. Do you agree? So we broke it down into its primes. What are we going to do? It's a cube root, so we're going to group them into groups of 3. It's cube root, so we group them into 3s. Right? It's a cube root. So we group them into 3s. And so, what do we do with this? 2 times 2 times 2, what's the cube root of 2 cubed? It's just 2. So it's going to be 4. Now what do I do with that 2 when I bring it out front? Multiply it by that 4 right there. Okay, bring this 2 out here, multiply it by that 4. Alright, so that cancels, and what do you have left? You have a cube root of 3 left over. Everybody see that? Okay. And then let's just rewrite this. Getting a little ahead of ourselves. Haven't even got to this one yet, but let's just do that anyway. So what do we got? We got 2 cube root of 3 plus, let's do this. 4 times 2 is 8, and this is the cube root of 3. We got one more to do, don't we? We have the cube root of 81. Now remember, this is not the square root of 81. A lot of people get confused with that. It's not the square root of 81, it's the cube root of 81. So what am I going to do to 81? I'm going to break that down into its primes. So let's think. What times what's 81? Okay, 9 times 9, right? Tell you what. Let's do this in our head. 9 times 9, so that's 3 times 3, that's a 9, and then another 3 times 3, that's a 9. So it's broken down into its primes. Do you really have to do that factor tree with those little lines every single time? No. Hopefully you can kind of get away from that and do a lot more of that in your head and break it down just like this. Now what do? It's a cube root, so we group them into 3's. So this is like 3 cubed. So the cube root of 3 cubed is just a 3. So that goes here. What's left over?
3.
The cube root of 3. Okay? Everybody see that? That's what we were doing earlier. And then let's just write this down like this. Now, up here you couldn't add those together, could you? Because this is a cube root of 3, this is a cube root of 24, this is a cube root of 81. They weren't like terms. You couldn't add them together. But we took the ones that we could simplify, and we did. We simplified it to this. Now let's take a look at them. Now are they like terms? Yes, they are. They all have the cube root of 3 in it. So now I can take the number out in front, the coefficient, and I can add those together. So 2 plus 8 is 10, minus 3 is 7. So it's just 7, what? Cube root of 3. All right? And that's how you write it. So what are you adding? You're only adding the coefficients, aren't you? The 2 plus the 8 minus the 3. But you keep your term the same. All right? Keep the square root of 3, or the cube root of 3, just like that. All right? So you just added the coefficients. You stuck it. Remember, pretend that it's kind of like an x or a y, a variable. All right? You should be able to do that. If you had like 2x plus 8x minus 3x, that'd be easy for you. Right, Norval? Come on, keep your eyes open, please. So 2 plus 8 is 10, minus 3 is 7x. That's easy for most people to see. Is for some reason, when you start putting roots in there, square roots or cube roots, it gets a little more complicated, but really it's the same thing. It's almost the same exact thing. You okay with that? That's not so bad, is it? All right, let's do another type. And was there really anything brand new in that? There wasn't anything brand new at all, because we learned on Thursday how to simplify these roots. You already knew before even coming into this class how to add like terms together. All right? You might not have added like terms when they were square roots or cube roots, but you knew the process, didn't you, for adding like terms? So really there was nothing brand new to this. It was a couple things that we learned at different times, and we just kind of put them together into one problem. That's what we're going to do with this one, this next one as well. Remember the distributive property, right, or FOIL method? Well, that's what we're going to do right now. But we're going to do it with roots. So let's find a good one. All right, let's do this one. Square root of 5 plus square root of 2. And then the square root of 5 minus the square root of 2. This is kind of one of our special type. Do you remember what type this is? They both look the same. Good, you see it already, don't you? They look the same except one's plus and one's minus. So they are different, but they're different just by a sign in the middle. And this is the difference of two squares. So hopefully that helps you out a little bit. Because remember, all you got to multiply when it's the difference of two squares is the first and the last. What's going to happen to the outside and the inside? They add up to 0. Very good. Okay, they add up to be 0. So really, all I got to do is two multiplications here: the first and the last, recognizing that it's a difference of two squares. Okay, so let's do that. Square root of 5 times square root of 5. Is it 25? Let's do it off to the side here. The square root of 5 times the square root of 5. Went through the, what is it? It's just 5, isn't it? It's just plain old 5. How'd you get that? Well, you could go through the whole process if you wanted to, right? Put it under one square root, right? You remember that rule, don't you? And then what's that? 5 times 5 is 25. The square root of 25 is 5. But we went through this routine before. Because what would the square root of, I don't know, 15 times the square root of 15 be equal to? You could put that into a calculator, right? 15 times 15, take the square root, but guess what you're going to get? You're going to get 15. In fact, you could do it with crazy numbers, like the square root of 57 times the square root of 57. What's that? It's just 57, isn't it? So learn that idea right there A square root times itself. Now, why does that work? Let me show you. Because what did I do? I multiplied by itself. I took a number and multiplied by itself. What are you doing when you take a number and you multiply it by itself? You are doing what to it? What if I take a number, 3, and multiply it by itself? What am I doing to that number? Come on, guys. You're squaring it. Thank you. You're squaring that. It's 3 squared. Okay, it's 3 squared. So watch this. If I took the square root of 5, multiplied it by itself, really, what am I doing? I'm squaring it. What happens? The square root and the square, they're kind of inverses of each other. What do you think happens to them when they're inverses of each other? They cancel each other out, and you just get a 5, don't you? It's the same thing as square root of 57. Square root of 57 times square root of 57 is this. It's the square root of 57 squared. What happens with the square root and the square? They cancel each other out, and you're left with 57. Does that make sense? Okay, so let's go back to this. Square root of 5 times square root of 5. You should be able to do that in your head without writing all this stuff out. What's the square root of 5 times the square root of 5? Just 5. Okay, that's the first. What about the signs, though? It's positive times negative, which is negative, okay? Because it's the difference of 2 squares, right? What about the last? Square root of 2 times square root of 2 is?
2.
It's just plain old 2, right? You could think the square root of 4 and then the square root of 4 is 2, but it's a lot easier saying square root of 2 times square root of 2. Oh yeah, that's just a 2. Or it's the square root of 2 squared, which is a 2. 5 minus 2 is 3, and that's your answer for that right there. Pretty simple, isn't it? Now, I picked a nice one that was a difference of 2 squares. That came out pretty easy when it's a difference of 2 squares like that. They're not always going to be like that. Let's do one that might be a little bit uglier than that. Let me find one. Okay, here's one. Let's do this one. 4 squared of 5 minus 1. And then 3 squared of 5 plus 2. Now on this one, this is not a difference of 2 squares, so we're going to have to go through the whole FOIL method, the whole distributive property. Again, distributive property is not new. FOIL method is not new for us. The square roots, multiplying square roots now is not new for us. But putting the two things together is a little bit new. All right? And that's all we're doing. We're taking 2 old things that we've already learned about and just putting them together. So let's do this. Let's do the first. So if I multiply the first terms, 4 times 3 is 12. Times what? Square root of 5 times square root of 5, which is 5. Okay, without doing too much in our head, let's just write 12 times 5. Is that all right? Okay. All right, that was the first. What about the last? Or I'm sorry, the outside. The outside. 4 square root of 5 times 2. So it's just 4 times 2, which is 8, and then square root of 5. It's a plus because they're both positive. That was the outside. Let's do the inside. It's a minus because it's a negative times a positive, and it's 1 times 3 square root of 5. So that would just be 3 square root of 5. And let's do the last now. Negative 1 times positive 2, it's negative 2. And we're not going to leave it like this. We need to simplify it. So let's do the 12 times 5 first, which is 60. All right. I tell you what, let's just do that in our head. So that's going to be a 60. What? Minus 2, right? 60 minus 2. So what's 60 minus 2? It's 58. You should be able to do that part in your head, don't you agree? That and that. Okay. What about this stuff right here? They're like terms, aren't they? So we can add those together. So this is 8 square root of 5 minus 3 square root of 5, which is positive, so it's a plus 5 square root of 5. Make sure you put the plus there. Don't just put the number next to the 58, okay, with nothing in between. All right, you put the plus there because it's a positive. Can you do anything else with those two? Nope, that's it. And that would be your answer right there. You can't add those together. That doesn't have a square root of 5. You can't go 58 plus 5 is 63. You can't do that because this doesn't have a square root of 5 with it. All right, they're not like terms, are they? So you can only keep it like that. That's the only way to keep it. There you go. Think you can handle that? Okay. It's just distributive property. You know how to do that. And you just have to know how to multiply square roots together. And lately we've been talking about how to do that. So you should have that stuff down. All right. That's enough information. Yep. So you got 2 of each. You got 2 where they're like this. Okay, like this kind of thing where you simplify and then you add like terms, and then you have two of these where it's FOIL method. Okay, both of them are FOIL method. One is actually the difference of two squares, and then one is not. So they're very, very similar to the examples that I gave. So you should be able to do. So now, what are you doing? You're doing section 17A again, but we're doing 9 through 12 this time. All right, that's due tomorrow. Please try these. Don't wait till I just read off the answers tomorrow and then write down the answers. Make sure you at least attempt them. Okay, attempt them. And then you'll know when we go over how to do the problems, if you at least tried it, you'll have a better idea of how to do them tomorrow when we go over it. If all you do is say, well, you know what, I'm not even going to try it, he's just going to read off the answers and show us how to do it in class tomorrow. If that's your thought process, you're not doing what you should be doing, okay? You're not really going to learn that way. You only learn by doing it yourself, okay? Unless you try these yourselves, you're not really going to learn this stuff. So you got to make sure that you try these yourself. All right, that's it. Easy homework. 4 problems, and that's due tomorrow. Remember, check your lesson plans for Wednesday, okay?